in my previous video, I explained about n-bit ripple carry adder. So that is having some limitations. To overcome that limitations or the disadvantages, we go for carry look ahead adder logic. So in this video, I am going to explain about carry look ahead adder logic. But let us see again. What are the disadvantage or limitations of this ripple carry adder? As the name indicates, this adder ripples the carry, that is propagates the carry. That means when I am adding these two bits, so whatever the carry generated here, that will be passed as input to the next stage. Similarly, when I add this stage, the carry generated in this stage is given as input to the next stage. That means this stage is waiting for carry to be generated from the previous stage. Similarly, this stage is waiting for this stage waiting for this stage. That means this stage is waiting for these two stages. Similarly, this stage is waiting for these three stages. That means unless one stage produces the carry to the next stage, so that the next stage is not going to add. That means even though I am having all the bits of x number, all the bits of y number, still I am having all the bits of the two numbers, which is not possible to add parallelly because each stage is waiting for the carry to be generated at the previous stage. So that we discussed in this diagram. So again, see, whatever this full adder generates this carry, that is given as input to this one. Now this will take the input of this carry and these two bits and then it put as some bit. That means each adder is depending upon the carry generated in the next stage, previous stage. This is a disadvantage. One more disadvantage. See, now we derive from the truth table of the full adder. From the truth table of the full adder, we derive the equation for the sum bit and we derive the equation for the carry bit, carry out. Okay, so this is the equation for carry out, this is the equation of sum bit, and this is the circuit for sum bit. I am having only one gate. Once I given all these three, so this one gate takes some propagation delay time and it produces output. So it takes, that means each sum bit, yes, not takes one gate delay, yes, no, it's not, okay, S1, like that, S2, S3, then each sum bit takes one gate delay. Similarly, carry. So carry, this is the equation. So this is the AND gate. So when I give all these inputs, all these are same gate. So it will take same amount of time. So one gate delay. And then after these outputs are given as input to this one and this take one more time. So two gate delays. Two gate delay for this one. Okay. So this is what? 2 gate delay for carry out. So totally to one full adder takes one gate for sum bit, total 3 gate delays. Okay, now so this one cannot add until its previous stage generates the carry. So this will take 2 gate delay for this carry. So this will take one, sum bit can take 1. So 2 plus 1, 3 gate delay. And this is 2 and this depends on the previous one. This 2 plus this 2, 4. So similarly this 6, this 8. So that means the time delay from one state to keep increasing. 2 gate delay, 4 gate delay, 6 gate delay, 8 gate delay, 10, 12, then it goes on. Suppose I am adding two 64-bit numbers, assume each gate is taking 2 microsecond, means 128 microsecond. 128 microsecond means 0.128 milliseconds. That means that much amount of time it is taking only to generate the carry. So that dependency we need to remove. So that means this is slower because suppose see we are adding 64-bit number means 64th stage has to wait for all these previous 63 stages. Then only I can add. Okay, so that's why it is slower. Okay, so this ripple carry adder is a slower circuit because it depends upon the carry generated in the previous stages. So in order to design the fast adder, we have to eliminate this dependency. That means if we remove this dependency, so then we can able to design a fast adder. Such a fast adder is called carry look ahead adder. That is what I am going to explain in this video. So hope you understood till now the disadvantages of ripple carry adder and why we go for the carry look ahead adder logic. We know that sum bit is obtained by this equation. Sum bit is equal to xi exclusive or yi exclusive or ci, and we know that carry out, that is ci plus 1, is equal to xi yi plus xici plus yici. This is the equation, we know that. Okay. So now the carry look ahead adder. So why we go for to eliminate the disadvantage of ripple carry adder. That means here each says that means C1 is depending, carry generated in the first stage is depending upon the C0. Similarly, carry generated in the second stage is depending upon the carry generated in the first stage. That means each stage is depending on the first stage. Okay, that dependency if we eliminate, then we can design the faster adder. So to eliminate the dependency, let us consider this equation and I will rewrite the same equation in another way. Okay, let us write the same equation. Ci plus 1 is equal to, I am writing this as it is. Here, what is common in these two terms? Ci is common in both the terms. If I take Ci common, so I will get xi plus yi. Okay, now the same thing will rewrite as it is because a into b is same as b into a. That means 5 into 4, 4 into 5, both are same. So instead of writing ci into x plus iy, xi plus yi, then into ci I will write. Same, I will write. Instead of a into b, I will b into either side. Okay. So now this I am going to write in the form of, now I am going to write the same equation. Now ci plus 1, instead of xi yi, now I am going to write gi plus, instead of writing x plus yi, I am writing pi. Okay, now I will call this equation as, let us call this equation as 1, this equation as 2, this equation calling as 3. Okay, so now here what I written, so here I written gi is equal to what? In place of j, what I written? xi yi. That means in place of xi yi, I written gi. Similarly, in place of x plus xi plus yi, what I written? Pi. Whereas this gi is called carry generate function and this is called carry propagate function. Gi is equal to xi into yi, that I am calling as a carry generate function, and pi is equal to xi plus yi, which I am calling as carry propagate function. Now when this carry out will be 1, that means when I add 2 bits, when I add any 2 bits, when that state generates the carry, if gi is equal to 1, that means if gi is equal to 1, what happens? Ci plus 1 is equal to 1. Gi is equal to 1. Then plus, I don't know, whatever it may be the pi plus ci. Pi into ci, whether it may be 0 or 1 this term. Whether this term is 0, then also ci is equal to 1. 1 plus 0 is 1 only. Suppose if this bit pi into ci is 1, 1 plus 1 also 1. Okay, r, because plus is nothing but r gate. 1 or 1, 1. 1 and 1 or 0 is also 1. That means if ci plus gi is equal to 1, if gi is equal to 1, then no need to depend upon ci. That means when gi is equal to 1, if xi is equal to 1 and yi is equal to 1, then gi is equal to 1. That means carry generate function becomes 1 when both are 1, 1. When both are 1, 1, that means suppose see, I am taking some bits. See, when both bits are 1, definitely it produces carry to the extent. Definitely it produces carry 1 to the extent because 1 plus 1, 0 carries 1. See, suppose if any one is 1, if see here this is 1, 0 or this one or this is 1, 0. Any one is 1, see it is not producing carry. J is 1. That means when both are 1, 1, obviously carry will be generated. That means Ci is equal to, our carry will be 1 if Gi is equal to 1. Now, suppose always both bits are 1. No. Sometimes both are 0 or any one is 0. If any one is 0, what happens? If any one is 0, that means what? Xi is equal to 0 or yi is equal to 0, then what happened? Then gi is equal to 0 because both are 0 means what? Gi is equal to what? Xi into yi. If any one is 0, 0 into 1, 0 or 1 into 0, 1, 0. So, but if any one is 1, Pi is equal to what? Pi is equal to Xi. 0 plus 1 is what? 1. Or 1 plus 0 is what? 1. So then J is equal to 1 and Pi is equal to 1. Why? Because 1 plus 0 or 0 plus 1 is 1 only. So Pi becomes 1. When Pi becomes 1, when Pi becomes 1, so when Pi becomes 1, so this becomes 0. 0 plus this becomes 1 means 1 into Ci. That means Ci plus 1 is equal to Ci if Xi or Yi is equal to 1. That means carry generated in the next stage is depending upon its previous stage only when any one is 1. If any one is 1. Any one is 1 means not both 1. Both 1 means Gi becomes 1. Both 1 Gi becomes 1. So I can write Pi is equal to Xi exclusive or Yi. Okay. So see, now I want only two things. So one, how I got this equation 3. So simply I am taking the Ci common and I written like this. In place of Xi, Vi, Yi, I written Gi called carry generate function. Then in place of Xi plus Y, I written Pi. This I will call carry propagate function. And from that I have shown when the carry is 1, if both are 1, if any one is 1. That's it. Understood? Now, what I told, in order to design this fast adder, we need to eliminate the dependency. Okay. So let us prove that. Okay. I will rewrite this equation 3 once again. That is Ci plus 1 is equal to what? Gi plus Pi into Ci. This is the same thing I rewritten. Now, what I will do, now I will put I is equal to 0. If I put I is equal to 0, so then what happens? 0 plus 1, 1. That is now C1 is equal to G. I place 0, 0 plus P0, C0. So that means C1 is depending upon C0. Obviously, initial carry C1 has to depend on C0. Now let us see the equation for C2. So C2 means what? I will put I is equal to 1. When I put I is equal to 1 in this equation, I place 1, 1 plus 1, 2. That is C2 is equal to what? G1 plus P1, C1. C2 is depending on C1. Yes, according to the ripple carry adder, C2 is depending on its previous state, that is C1. Now, but I know what is C1 value. So in place of C1, now I am replacing in place of C1, I am replacing this value. So G0 plus P0 into C0. Now I will multiply these two. So I will get C2 is equal to G1 plus P1 into G0 plus P1 into P0 into C0. Now if you observe, see actually C2 is depending on C1, but we have eliminated that now. See, C2 is depending, see there is no C1 anywhere in this equation, only C0. That means C1 is also depending on C0, C2 is also depending on C0. C2 is not depending on C1, this depends will be eliminated. That's the beauty of this logic. Now let us see, put now I is equal to what? 2 in this equation. If I put I is equal to 2 in this equation, 2 plus 1, 3, that is C3 is equal to, in place of I 2, so G2 plus P2, C2. But I know the value of C2, this is the value of C2. Now I will replace this G2 plus P2 in place of C2. Now I will, in place of C2 now I am replacing this value. That is nothing but what? G1 plus P1 into G0 plus P1, P0, C0. Now if I multiply this, now what I got? C3 is equal to G2 as it is plus P2 into G1 plus P2, P1, G0 plus P2, P1, P0 and C0. Now again if you observe this equation, see C3 is nowhere depending on what? C2 or C1. C3 is depending only on C0. See, earlier C3 is, according to ripple calendar, C3 is depending on C2. That dependence has been eliminated. C3 is depending only on C0. C2 also depending on C0. Similarly, if I write C4, this becomes G3 plus P3, P3 G2 plus P3 P2 G1 plus P3 P2 P1 G0 plus P3 P2 P1 P0 into C0. That means again C4 is also depending on only on C0. That means no carry is generated depending on the previous one. All the carries C1, C2, C3, C4, C5, Ci plus 1, any carry is depending on only on the initial carry C0. That's it. We have eliminated this. That means if I know a G0 P0, G0 P0 means what? G0 is equal to X0 into Y0. G1 is equal to Sy. That means if I know Xi and Yi bits, if I know initial carry, we can generate the carry bit at any stage at the same time. Previously in ripple calendar is what? 2 gate, 4 gate, 6 gate delay, 8 gate delay, 10 gate. It is increasing. But now at the same 3 gate delays, we can generate all stages carry at the same time. Parallelly we can add. That's what. That means no need to, depending on the carry, I can generate C1, C2, C3, C4, C5, any stage ahead. If I, as soon as I know C0. That means I can look ahead, look forward the carry in order to add all the bits, all the stages of the bits of the two numbers. That's why the name carry, look, add, adder. Now hope from this mathematical proof we'll came to know that any stage carry we can generate without depending upon the previous. If we know only the initial carry, we can start adding all the stages parallelly with the concept of this one. Hope you people understood. Now, with this equation, now I am going to make the circuit of these things. Okay? We know this carry 1, according to this carry look adder, carry 1 is equal to G0, P0, C0. G0 is equal to what? Gi. We know that what? Gi is equal to Xi into Yi, and Pi is equal to Xi exclusive or Yi. We can write instead of Xi plus Y, because any one should be 1. Any one means exclusive or, so I have done like this. Okay. So now let us write the equation for this one now. C1 means what? G0. G0 means what? X0 into Y0. That means I need one AND gate. If this is my X0, this is my Y0, I will get what? G0. So G0 I got, so P0 is what? Exclusive OR, right? So that is now one exclusive OR gate. Same thing, this is X0, Y0. Okay, I got here P0, here I got G0. So this P0 into C0 I get. So that means one initial carry, that is C0. This is what? P0 into C0 means what? AND gate. So AND gate, so this is AND gate. Now I am getting here what? P0. Here I am getting what? Here I am getting P0. This is C0. I am getting P0 into C0. Here I am getting G0. Here I am getting G0. Okay. So now these two, now what I have to do? These two I need to R. That is R. Okay. So R gate. Here I will get C1. So C1 is equal to what? G0 plus P0 into C0. Okay. C1 is equal to what? G0 R plus P0 into C0. I got this equation. Now, if you observe here, as soon as I apply G0 and P0, so both are taking only one gate. This is one gate, this one gate, commonly one gate. So this is one gate delay. And then after that, for this, I cannot directly this one. It takes some time. So this is another one gate. Here one gate delay. Here one gate delay. Here one gate delay. So totally what? 3 gate delays. That means I can obtain C1 at the 3 gate delay. Similarly, let us take C2. C2 is equal to what? C2 is equal to also 3 gate. See, same 2 OR gates. 3. C2 also 3 gate. C3 also 3 gate. C4 also 3 gate. That means all carry I can generate at the same 3 gate delays. Same 3 gate delays. Now let us write some equation. Some equation is equal to what? Xi exclusive or Yi exclusive or Ci. Right? In order to eliminate the dependency of the previous carry, we need to generate, we have to use this what? We have used carry generate functions, carry propagate functions. But GI, PI, I know to generate this carry generate function, propagate function. So now I am using, see, so this is one AND gate to generate carry GI function and one more exclusive OR gate to generate PI. Okay. Now this is my x naught y naught. So let us say this is say xn minus 1 yn minus 1. Same thing I am giving. Okay. Here I will get what? Here I will get yet okay g naught p naught. This is gn minus 1 pn minus 1. This is the circuit to generate what? Carry generate function and carry propagate function for all the stages from 0 to n minus 1. Or you can start from 0 here and n minus 1, not a problem, both are same. Okay, so I've generated. Now using, but my intention is what? To add. So add means what? I need to get this equation. To get this equation I need what? Gi also I need, Pi also I need, Gi, Pi. So how to get Gi? How to get Gi? I am getting Gi by multiplying what? By multiplying or adding xi and yi, and I am getting Gi. And how I am getting Pi? I am getting Pi by exclusive ORing this xi, the same thing, this xi, and xi and yi I am taking. Okay, now here I am getting what? Pi. Okay, Gi I am getting, Pi I am getting. So now how to get this one? Pi means what? This is already exclusive or xi exclusive or yi I am getting, plus exclusive or ci I need. Okay, so I will take one more. So this is my ci, and these two again I will do what? Exclusive or. Now here I am getting what? Here I am getting, see, this output of this is what? Output of this is my Pi and this is my Gi. Pi is equal to what? Xi exclusive of I. Pi exclusive of Ci means some bit I am getting. So here I am getting some bit. So this is I am getting some bit. Okay. So same, this is bit what? This is my Pi. This is what? Gi. So this is the one bit stage cell to generate some bit propagation function, generate function, carry generate function, carry propagate function, submit to that one stage. Okay, so this I will call it as, this I will call it as one bit stage cell. But always we are doing only one bit? No, n number of bits. So there will be n bit stage cells are there. Or let us say 4 bit stage. 4 bit stage means this is for 1 bit stage. So now I am writing 4 bit stage cells means now 1 bit stage cell. I'm writing a little bit down just to accommodate the space. This is Si, this is Pi, this is Gi. Okay. Now this is my bit stage cell, bit stage cell, bit stage cell, bit stage cell. This one. Okay. So now to this actually I want to give it what? To this stage I need to give x naught, y naught. To this stage I have to get what? X1, Y1. To this stage I need to get X2, Y2. This stage I need to give X3, Y3. And this is my initial carry C naught. C naught. Now, if I give this one X naught, Y naught, C naught. X naught, Y naught, C naught, I will get what? C1. That means it produces what? It produces C naught. That, okay, it's okay. It produces C naught. Okay, now wait. Now this produces what? G naught, P naught. So I will get G naught here, P naught here. Okay, this will produce, similarly it will produce what? G1, P1. This produces what? G2, P2. This produces what? G3, P3. Okay. This is my carry look ahead adder logic. That means this is the equations. This is the equation. I am eliminating this dependency. That logic circuit here. That logic circuit here. Okay. So now this logic, see this stage is not depending on this stage. Actually, we are generating using this logic. I am always depending upon C naught only. So once I know C naught, once I know C naught, same thing as C naught I will give to here. So with this C naught, I can generate carry to the next stage. Okay, I can generate the parallel to all the steps, parallel to this everything. Okay, so this is nothing but my C1, this is nothing but my C2, this is nothing but C3, this is my C4. Now, each bit is generating what? One sum bit. Where is it? Some bit. Okay, so this is my S0, this is my S1, this is my S2, this is my S3. Now, finally, suppose always we are not adding only 4-bit stages. Okay, maybe 6 stage, 8 stage, 9 stage, 10 stage, whatever. Now it generates again carry propagation GI dash, PI dash. This can be given as input to the next stage. Okay, cascading. Okay, so this is my what? Carry look ahead adder logic. Okay, so basically from this equation we eliminated the dependency, we got this equation. This equation only we implemented in this logic. Okay, and this bit stays still. So with the carry generate and propagate functions, I derived the sum bit equation. Okay, and since to generate every carry at the 3-gate delays, here all carry will be generated at the same time at 3-gate delays only. No need to depend on the previous stages. So this is how this adder circuit look ahead the carry. As soon as I know xi bits, yi bits and initial carry, if I know this, parallelly I can add all the stages and I can calculate all the stages parallel to all the stages. No need depending on the previous stage. So it eliminates the dependency. Hence this adder is called fast adder. Whatever the adder circuit we are using in our system ALU, so all the ALU systems are using this adder circuit only, carry look at adder logic. Okay, so hope you people understood the concept of this one. If you have any questions or if you not understood, please write your questions or doubts in the comments. Okay, if you have not yet subscribed to my channel, please subscribe, and if you really like the channel, please inform to your friends and juniors. Thank you. Thanks for watching.